Hi, Matt Laumers again. So we have been solving features of quadratic functions. We have solved some of the questions about translation and transformation of the quadratic functions. So we didn't solve quadratic equations, yes. So let's continue solving some quadratic functions and their transformation question again. So you feel free to pause the video and then you can try it by yourself first. So which option will be correct? Then you can compare your answer with my answer, okay? So as you see here, the parent function of the quadratic function, which is f of x is equal to x squared, is given to us, okay? So there's a kind of transformation done to this function. As we know, f of x is equal to x squared. Let me draw it here. F of x is equal to x squared is a kind of parabola where the just vertex is origin, okay? We know this already. When we start the quadratic function graph, we see that f of x is equal to x squared graph is this, okay? Maybe my graph is not just so strong, but you can do it with your calculator, or you can do some online application. You can draw f of x squared, okay? So here, when we just checked h of x, we have negative x squared here, okay? So what is the relation between f of x squared and negative x squared? So have you ever wondered what is negative x squared? So negative x squared means all all just values of x squared is uh, just their values has been changed. I can explain with a table actually. For example, like when we have a one here input, okay, since we have a function, we have inputs and outputs. We have positive one here, okay? So it is for f of x. F of one is equal to, which is one square, it is equal to one, okay? Or we have 2, for example, here. When we have 2 or negative 2 on the left side, so when you have negative 2, what is f of negative 2? F of negative 2 is equal to what? F of negative 2 is equal to negative 2 whole square, okay, which is positive 4. As we see here, this parabola is upward, looking upward, facing upward, okay? As we know that the simple, just like, or this primitive graph of the quadratic function f of x is equal to x squared. So when we put negative x squared here, I'm trying to obtain another function which is starting with negative x squared, and negative 3 I will consider later, okay? Negative 3 I will consider later. So what kind of graph negative x squared has? So for example, at 1, when we plug in 1, let's say h of negative 1. What is h of negative 1? Negative 1 whole square. As you see from PEMDAS, we need to do quadratic first. Negative 1 square. Negative 1 square is positive 1, okay? We take the square first, not the negative we will consider later, okay? So negative 1 square, here, let me highlight it. Negative 1 square is positive 1. But this negative sign in front of it, I will consider later. I put it here already. So result is negative 1. As I put 1, then you will have a negative 1 result. Okay? When you put, for example, negative 2, h of negative 2 is equal to negative 2 whole square. Okay? So negative 2 whole square, we need to calculate first. Negative 2 whole square. Negative 2 times negative 2, which is positive 4, but this negative in front of it, we will consider it then. It means that whatever we have output values, their values are reflected according to x-axis. What I mean to say that if you guess the graph of negative x square is, as you know, it is facing down. Okay? Since there is a negative sign in front of it. You might know from algebra classes, this is positive x square graph, this is negative x square graph. Okay, facing down, as if x-axis is behaving here like a x-axis like a mirror here. Okay, let me just do it like a mirror. Okay, x-axis behaving like a mirror. Because of that, this kind of transformation, we call it reflection over the x-axis. So in this options, we need to check that reflection over the x-axis. Okay, so which one is the reflection over the x-axis? So a option can be correct and B option can be correct. Reflection over the x-axis. Not C and D. That is reflection over the y-axis, something different, okay? So after taking reflection, we need to consider here negative 3 also. Since negative x squared is a reflection, negative 3 is a number which is added to negative x squared, or sub 3 is not subtracted from negative x squared, which means, as we learned from the previous video, if something is added outside, that is vertical shift, okay? So since negative 3 is subtracted from negative x squared, means this red graph will come the 3 units down more, okay? That is negative, this blue graph, if you extend more, you can extend it, negative x squared, negative 3, okay? So first fall reflection over the x-axis and translated 3 units down. Okay, translated 3 units down is option A. I hope you got the video. If just calculator is allowed to you, you can open your calculator and you can draw it negative x squared, negative 3. As I have here, Rasmus calculator. When I put here negative x squared, as you see, reflection is taken. And then when I just type negative 3, as you see, that is negative 3 units shifted downward. Okay, that is negative x squared, negative 3 graph. I hope you enjoyed the video. See you in the next video.